everybody, it's Phil Kerner, the Tool and Die Guy, and this is part 2 of checking a block for squareness. I feel like I got enough commentary and enough emails that I perhaps didn't make this incredibly clear in my first video. I think a lot of guys got it, but I had a few people say the thing they're concerned about is that rolling the indicator is, I hope you've already watched the first video, and you need to if you haven't, because this won't make any sense to you. They're concerned that if this was a pyramid, that you'd never know you're a square. So I'm going to explain why you would know that. So this particular block of steel here, I literally put 3/1000ths of taper on a side, okay? So I'm going to stand this thing up here, and as it did in the first video, I'm going to check this block for squareness. So I'm going to roll my indicator over. I've got a 0 there. Then I like to check the side opposite of it. Let's see what we get. 0 there. That's a very square block that way. Let's go 90 degrees. And it's minus about 8/10. Gotta love the cast iron surface plate. And minus about 2,000. So this block is within total indicator reading about 1.8 thousandths out of square. That's really good for a mill. Okay, so now you're saying, well, you know, how do you know if this is a pyramid? Well, I've made a pyramid here, and what I didn't explain in the first video, and I apologize for that, a block of steel, or a block of anything, has 6 sides, not 5. So what we've done is check these 4 sides to the bottom, okay, and we know these 5 sides are square. Well, let's flip it over on the other side. The trick is, don't change this 0 now. Leave it alone. We had a 0 set on the other side. We know where we were at. Now all of a sudden we're plus 5 there. Let's go 90 degrees. Plus 5 there. Plus 6 there. And plus 5 there, 4 there. So what we've done is proven that this block is out of square by about 5/1000ths, and really what's not square is these 4 sides. The bottom and top are good, because if you do it this way, the readings all come in within a couple thou. If you do it this way, they come in with a couple thou of each other, but they from this side where we had set a 0 originally, okay, leave that alone. Don't touch that 0. Now flip it over. There's your 5/1000ths out of square. So don't forget, a block has, I know it sounds obvious, but you got to check both of the ends to see if you're square or not. Now this block's a mess, because this would be tough to re-square up, because if you ever got a situation like this, if I were to 0 this out here, okay, this block is very square both ways. Let me just do that for you. But I just told you not to do. So if I had started on this side, see, now this side looks like it's within 2/1000ths also. Okay, so again, the trick here is you got to flip the block back over and leave your 0 alone. And then you say, wait a minute, how can that possibly be? Look at that, minus 6/1000, 7/1000. So just remember, a block has 6 sides, and the only way to fix this particular block up is all 4 of these sides are going to need to be recut, and basically you would hold them in your jaws this way, because these 2 sides are nice and parallel, and re-skim all 4 sides, because what we've got is taper here. Okay, so one last thing I want to end up with. A gentleman did email me, and he said, you know, wasn't quite sure about my method. It was a very polite email, and I'm sure he's watching this. He used to use a method, and I've seen it, where you set your 0 on your indicator against a cylinder square, and basically a cylinder square is it's a round piece of steel. It's perfectly square, and you bump this up against that and set your 0. Now you're comparing it against something perfectly square. I get that. I never did that. We never had that equipment, so this is the way I learned it. But this does tell you that you're out of square, because if this block was perfectly square, it should read the same thing on all four sides. And to exaggerate it, if it's out of square like that, of course it's not going to be hitting. If it's out of square like this, it's going to be plowing into it. So, and we're only talking a few thousandths. One last thing I'll end with. You know, as long as my total indicator reading is within 5 thousandths on squaring up a block on a mill, I'm a happy camper. That means I'm within a couple thousandths of squareness per side. Good enough on a mill. When I get them this close, 2 thousandths, not bad at all. And if I had to get it closer than this, off we go to the grinder. And I would be using a surface grinder with either a precision toolmaker's vise, grinding vise, or a squaring fixture from a magnetic squaring fixture from like a Herman Schmidt company. That's the only other way. You know, I'm sorry. I mean, yes, I could play with this for hours and probably get this within a thousandths on a mill. But when you need it perfect, you got to grind it. So don't sweat it. Within 5 thousandths total indicator reading TIR on a mill, you're doing good. So I'm Phil Kerner, the Tool and Die Guy. I hope this clears a few things up, and you can always email me with still more questions if it didn't. We'll see you on the next video.